Here's an ellipse problem, in case you have trouble with one of the homework problems. It's number 23. We want to get the equation and sort of complete all the graph, like get the focus and everything like that for this ellipse. It's an unshifted ellipse. Center's at the origin. Let's write that down. Unshifted. Center is at the origin. And we've got a vertex at 16, 0. And so, in fact, the vertices are just going to be plus or minus at 16, 0. And then a random point, and it's very important that that's just a random point. It's not anything special about that. But we just know that the ellipse goes through the point 8, 6. Okay. We've done problems a little bit like this, but I just want to do one more. So we know from the that vertex being at 16, we know that A is going to be 16. Okay. And then what do we still need? Well, we know that the standard form is x squared over a squared plus y squared over b squared equals 1. Stop that. Okay, equals 1. And so that's going to be, we can put in the 16 squared. And I tend to not evaluate that kind of thing unless I really have to, because sometimes there's nice simplifications and cancellations. And so we need to know b. And what we know is that 8, 6 can be plugged in for x and y. Okay, so we're going to get 8 squared over 16 squared, and hopefully you can see that's where those kinds of cancellations are going to show up. We won't need a calculator. Plus 6 squared over b squared equals 1. Oh, that's one equation in one variable. Like, we can deal with that. Okay, so 6 squared over b squared equals 1 minus, and now 8 over 16 is just a half, so let's just rewrite that as 8 over 16 quantity squared. Well, that's just a half squared, or that's a fourth. So that's 1 minus a fourth, and so that's 3/4. Okay, and so cross multiplying we get 4 times 6 squared equals 3b squared, or b squared is going to be equal to 4/3 times 6 squared. Now that one we might as well multiply out probably. B squared equals, we could try to be clever about it, but it's not that important. 6 squared is 36, 4/3 of that is 48. And so we can square root. B is going to be equal to the square root of 48, and that 16 comes out, and so it's going to be 4√3. I'll just write it both ways. Okay. So 4√3. Okay, and of course b squared is what actually goes into the equation, so that's 48. So our equation is now going to be x squared over 16 squared plus b squared over 48 equals 1. And if I wanted to write that 16 squared as a 256, I could, but I don't know, I'm going to leave it as a 16 squared. Okay, it's kind of up to you. I'm sorry, that's a y squared. Just kidding. There we go. So there's our equation. And so in particular, that tells us the y-intercepts are going to be at at 0, plus or minus 4√3. And 4√3, if I evaluate that, that's going to be about 6.9. Okay. So in other words, it's going to be at 0 plus or minus 6.92, or 6.93-ish. Okay. Okay, so that'll allow us to nail down that. And then if I want the foci, we need to know c. And of course c squared is a squared minus b squared. Remember, it's a little tricky. With hyperbolas, you've got c squared is a squared plus b squared. With ellipses, it's a squared minus b squared. They're different. There are similarities, but they are different. And so you just have to be a little careful. So c squared is going to equal 256 minus 48, or c squared equals 208, and c equals square root of 208. Now that is a pretty random one. We can take some squares out of that, I'm sure. Let's see what it tells us. 4 root 13. That's pretty random. Equals 4 root 13. Let's get a number out of that. 14.4. 14.42. Okay. And so we could plot that. It's pretty close to 16. And in fact, I have it already pre-plotted here. Let's just clean that up. And so there's what we had, and then here's I've just plotted the foci here. And then that confirms, if you look at the plot, it looks like that maximum is somewhere between 5 and 10, somewhere in the 6-point-something range. And remember, that was 6.93. So it's almost 7, and that looks pretty good. So there's plus or minus 6.93 for the minor vertices, is what I like to call them. And here's the foci at 14.42, plus or minus. Okay.